Okay, 7.2 day 1 is finding complex roots or solutions of polynomial equations. In this lesson, we'll be using all of the skills that we have learned in the previous module, module 6, to factor any polynomials that we find to obtain the solutions. So in the first example, we have x cubed plus 7x squared. If we are looking for the zeros, we're going to set that equal to 0. And since we know that there's a GCF x squared, we can factor that out, and we'll have x plus 7 in the parentheses. Solving these two for 0 by setting them equal to 0, we will obtain the two solutions are x equal to 0, and there's a multiplicity of 2 because this would be a tangent if we were doing the graph because of the square from previous chapters that we learned. Second solution is going to be x equals -7, and there's a multiplicity of 1, so that would be a cross if this is a graph. So the two solutions are 0 and -7 for this polynomial. Second one is actually in the form of a cube, so we can rewrite this as x cubed minus 4 cubed, and we're going to factor this using two parentheses. So we have x minus 4. Squaring the first term, we'll have x squared. Changing the sign to plus, multiply the two terms, we'll have 4x, and then we square the last term, which is 16. And then the only 0 that we're going to get out of this, the real 0, is x minus 4 equal to 0, and we'll have x equal to 4. For the second one, since we cannot factor it anymore, we are going to use the quadratic formula. So that would be a, b, c. So that's negative b, which is -4, plus or minus b squared, that's 4 squared, minus 4 times a is 1. Right there in front of x squared is 1. And then c is 16, all over 2a, so 2 times 1. Simplifying, we have square root of 16 minus 64 over 2, and we will have -4 plus or minus square root of -48 over 2, and we can rewrite that as -4 plus or minus 2i, no, I'm sorry, 4i radical 3 over 2, and we can reduce it by a factor of 2 to give us -2 plus or minus 2i radical 3. And if anyone is wondering how I got this, I can show the work here on the side. Square root of -48 is square root of -1 times square root of 16 times square root of 3, and that's going to be I, and then this is 4, and that's radical 3. So that's 4i radical 3. Example C, finding all the roots. First of all, we have a x that is in common, so we can factor out the x, the GCF. We have x cubed plus 3x squared minus 4x minus 12. If we set that equal to 0, we will be able to solve for the 0. And we realize this is 4 terms here. We can actually either do factor by grouping, or we could use synthetic division. So let's actually do synthetic division, putting the coefficients of 1, 3, -4, and -12. And we are going to try 2. And this is coming from finding the factors of 12. So the factors of 12 are plus or minus 1, 2, 3, 4, 6, and 12. And so one of them is 2, so we're going to try 2 and see what that gives us. Bring down the 1, multiplying by 2. We have 5 and 10. We have 6. 6 times 2 is 12, and that will give us a 0. So that's how we know that the 2 is actually a 0. So we reduce it by 1 degree, and this will be the remaining. So we can also factor this into x plus 2 and x plus 3. So the polynomial can be factored in completely using the first factor that we factored out, the GCF. We have x, and then we have the second 0, which is x minus 2, and then we have the last two factors that we found, x plus 2 times x plus 3. Setting it all equal to 0, we will have the zeros will be 0, 2, -2, and -3. And that is the complete set of solutions for this problem. Number 4, finding the zeros. We have, first of all, this is factored into a quadratic form. And so we have a difference of squares, so we could factor this into x squared plus 4 and x squared minus 4. Setting that equal to 0, we also realize this is a difference of squares, so we can factor that further into x plus 2 and x minus 2. And then bringing down, this is the complete factorization, and now we're going to solve individually for 0. So for the first one, we have x squared equals -4, so x is going to be plus or minus 2i. For the second 2, we're going to have x equals -2 and 2. And so the complete list of zeros are x equals plus or minus 2i and plus or minus 2. Those are all of the zeros. This one is also involving a polynomial. So we're going to try to use the synthetic division again. So we have 1, 5, 6, -4, and -8. And we're going to try 2. Let's see if that works. So let's try 2. 1 times 2 is 2. That's 7. That's 14, 20. That's 40. And that's 36. And obviously we are not going to get anywhere with this one. So we're going to actually try another one. So we'll try 2. And bringing the same numbers here. We have 2. Adding 5 and 2 is, we're going to actually try -2. So we have -2, and that will be 3. -6 will give us a 0, and that's a 0. -4, adding -4 and 0, that will be -4, and then we'll get 8, and then we're actually combining -8 and 8 to give us a 0. So this is actually a 0, -2. So we found one. We're going to reduce this to x cubed plus 3x squared, and then we have a 0x minus 4. And then let's rewrite the polynomial as x plus 2 times x cubed plus 3x squared minus 4. And I believe that will be the only 0 is going to be -2, the real one. And we will not be able to factor any further. So I will stop the problem here. And that's a wrap for lesson day 1 of 7.2. This discussion question described the apparent relationship between the degree of a polynomial function and the number of 0 it has. So in general, x to the n power for n degree will have n zeros. So that's the number of zeros that it should have. If it's x to the third power, you should have 3 zeros, whether they're real or not. So that is the end of the problem today. So you need to pause the video and go back to any of the problems. You may do so. And then you can do your homework after this.